This video is about word equations. Now, the first thing I want to stress here is that all the stuff you have learned about names of compounds, going from names to formulas, that's all still true. Just because we're putting these names into a chemical equation does not change the naming rules. So if it was silver chloride was AgCl before, it's still AgCl. No rules have changed. But in a word equation, we take those names, we put them together into an equation that shows us something that has happened. Okay, so a word equation or any kind of chemical equation represents a chemical reaction. So if I have something like silver nitrate adds to sodium chloride to form silver chloride and sodium nitrate, what I know silver nitrate is, what I know sodium chloride is, what I know silver chloride is, and what I know sodium nitrate is, doesn't change. So I would simply write that as silver nitrate I know to be AgNO3 plus sodium chloride I know to be NaCl. Reacts to form, that's going to be an arrow. That arrow guy means yields. These things here on the left side of my arrow are reactants, R-E-A-C-T-A-N-T-S, reactants, and they are going to form products. So reactants, products. AgCl plus NaNO3. Okay, so I simply took what I saw and I wrote it into a formula, a chemical equation. Now, usually there's more information in that chemical equation than just this. So instead of this equation, maybe they say something like a solution of silver nitrate adds to aqueous sodium chloride to form solid silver chloride and aqueous sodium nitrate. In general, when things react together, they are usually solutions. That is, it's not the solid anymore, it's the solid dissolved in water. Now be careful. A solution, an aqueous solution, is not the same as a liquid. This says a solution of silver nitrate. It doesn't mean I melted the silver nitrate. It means I took the solid silver nitrate and I dissolved it in water. Now to put these things in my chemical equation, I would say, once again, AgNO3, in parentheses I write AQ. That means aqueous. That means it's dissolved in water. Sodium chloride is similarly aqueous. Aqua, water, right? Aqueous. Then it tells me that my silver chloride is a solid and my sodium nitrate is also aqueous. This is a reaction some of you have been doing in science fair. Now there are some other symbols you might see. So to recap, AQ, aqueous. It's a solution in water, necessarily in water. S means solid. L means liquid, though as I say, not really very often do you have a liquid. Water is about the only liquid you usually see. And you'll notice I didn't put water in here at all. I said it was an aqueous solution, but water is not in here explicitly. There's no H2O here at all. You might see a G, a lowercase g, that's gas. Okay. All those things might be in parentheses after a formula. Other symbols you might see in an equation. You might see a triangle, either above or below the arrow. That means heat. Okay? That means they heated it up. So, for example, you might have written CuSO4.5H2O heat CuSO4 plus 5H2O. It's that heat that caused that bond to break. Okay? If you see an arrow pointing up, so something like H2CO3 yields H2O plus CO2. That one's probably aqueous. That one would be liquid. What you might see, this guy, CO2, that's carbon dioxide. It's a gas. What you might see in place of this is an arrow up. That just means it dissipated out into the universe, right? It evaporated. So that's what that arrow pointing up means. It means it evaporated. You didn't collect it or anything. What you might see is a compound written over the arrow. So something like H2O2 yields H2O plus O2. And then up here it might be like KMNO4. That thing written over the arrow like that, that is a catalyst. I know you learned about catalysts last year in biology. A catalyst is something that is put into the reaction to help it along, but it's not a reactant. It's not a product. You put it in and you take it out again and it's not changed. So that's why they stick it over the arrow. Right? There are others, but for the most part, those are the common ones. That's what you're likely to see. Okay, now, let's think more about this reaction here. I'm going to rewrite it. H2O2 yields H2O plus O2. Check this out. I've got two H's on this side, and I've got two O's on this side. On this side, I've got two H's, but I've got three O's. I can't have this. I cannot write this reaction just like this. And the reason goes back to conservation of mass, Dalton. I have to have the same atoms at the beginning as I do at the end. Matter can never be created or destroyed. So if I have two H's and two O's here, I have to have two H's and two O's here. So what we need to do is something called balancing. Okay? Balancing. Balancing is easy, honestly. You follow a couple of rules, and then you just hit it with a hammer until it works. That's really the secret. When you are balancing, you can put a coefficient. Remember in math, if you say 3x, the 3 is a coefficient? Okay. You can put a coefficient here, 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 outside of anything. What you cannot do is put any kind of coefficient in the middle. Okay? You can't like sneak a number here and say I have two O's, and then I have two O's and two O's. You can't do that. It doesn't work. These things, H2O2, H2O, O2, these things come as a set. I cannot change the ratio of H's and O's here in hydrogen peroxide. I can't do it. That would be the same as changing these subscripts, and you know I can't do that. I laboriously remembered that hydrogen peroxide is this. I cannot change these subscripts. Okay, so when you are balancing, do not change subscripts. Okay? Don't do it. Remember what I said. Formulas are formulas, whether they're part of a chemical equation or not. So, how do we do it? Well, let's see. I notice that if I put a 2 here, let me get rid of these circles I put in here. Now, I notice that if I stick a 2 here in front of that water, now I have 2 waters, which means I have 4 H's and 2 plus 2, 4 O's. Ah, look. If I put a 2 here, I also have 4 H's and 4 O's. This is now balanced. All these numbers are the same. Let's try it again. Na3PO4 plus H2SO4 yields Na2SO4 plus H3PO4. These would all be aqueous. Okay, let's balance this guy. Now it is easier when you are just beginning to lay out what you've got. Pretty soon you won't need to, but let's do it. I've got here 3 NAs. Now, note the polyatomic. You can treat it as one thing. You can keep it together because you'll notice it's staying together. I've got PO4 on the reactant side. I've got PO4 on the product side. So don't try to add all these different O's together. You will get confused. Just say PO4. You've got 1 PO4. You've got 2 H's. You've got 1 SO4. On this side, you've got 2 NAs. Let's keep them in the same order so they're easier to deal with. You've got 1 PO4. You've got 3 H's and 1 SO4. Okay. 3 NAs, 2 NAs. The only way to make those the same is least common multiple. So I'm going to put a 2 in front of Na3PO4. Now I have 6 NAs and 2 PO4s. And then I'm going to put a 3 here. Now I have 6 NAs and 3 SO4s. Oh dear, my PO4s and my SO4s, they were balanced, now they're not. That's all right. 2 PO4s, only 1 PO4. Let's put a 2 here. Now I have 2 PO4s, and I have 6 H's. Oh, look. Let's put a 3 here. That gives me 6 H's and 3 SO4s. Look, the SO4s balanced themselves behind my back while I wasn't looking. Ha! I'm balanced. 2 moles of Na3PO4 react with 3 moles of H2SO4 to give me 3 moles of Na2SO4 plus 2 moles of H3PO4. That's what these numbers mean. They are moles. By the way, I didn't say this, but you'll notice here there is no number. That is a 1. It's not a 0, it's a 1. It's like in math class, if you have just X, that really means 1X. Okay, not 0. There is 1 mole. This is 2 moles of H2O2 yields 2 moles of water plus 1 mole of O2. That's really all balancing is. Just keep trying coefficients and changing numbers until everything works out. Now, one kind of reaction is just a little harder, so let's do one. Let's say I have C3H8 plus O2 yields CO2 plus H2O. You will notice this O has split into 2 different things. If ever you have a reactant where it's in one place on one side and 2 places on the other, here is my advice to you. Now, this is not a hard and fast rule. This is my advice from years of experience. Do everything else first and hope that one balances itself behind your back while you're not looking. Because it's really hard to keep track of it going in 2 separate places. So, here's what I'm going to do. I'm going to do the C's first. I have 3 C's over here and only 1 C over here. Might as well list them out. I have 8 H's over here and 2 H's over here. I have 2 O's here and I have 3 O's here. Okay, now I'm going to do the C's first. I have 3 C's. So here's my 3. 3. Let me do the H's before I change the O's. This 8 here, I have 8 H's. I have 2 here. Let me put a 4 there. That's why I wanted to wait. Because now let's change those O's again. So now I have 8 H's, 3 C's. My C's and H's are balanced. Let's look at the O's. 6 and 4 is 10. 10. Oh, look. I can put a 5 there, and I'm balanced. And that works. Okay? But what if I have C4 H10 plus O2 yields CO2 plus H2O. Okay, same advice. C's first. A 4 there. Now I have 4 C's and 4 C's. 10 H's, 2 H's, 5 there. Okay, now let's total. 4 C's, 4 C's. 10 H's, 10 H's. 2 O's, 8 plus 5, that's 13 O's. Uh-oh. Look at the problem. There's nothing I can put here that times 2 would equal 13. It doesn't work. The only thing I could put here would be 13 halves, and I can't do that. These have to be whole numbers. So the only thing I can do is multiply this equation by 2. I'm going to put a 2 here. Now I have 8 of those and 20 of those. We'll ignore the O for the moment. If I doubled that, I have to double this. So this is now an 8, and this is now a 10. Now I have 8 of these, 20 of these. My C's and my H's are balanced again. Now, though, 8 times 2 is 16. 16 plus 10. Now I have an even number. So I can put 13 there. Now this is balanced. 2 moles of C4H10, which you remember is butane, plus 13 moles of O2 yields 8 moles of CO2 plus 10 moles of H2O. Sometimes in this kind of equation, these numbers can get pretty big. That's okay. Don't get nervous about big numbers. The only thing you do want to make sure of at the end is that all of them aren't divisible by 2, because you do want lowest ratio coefficients. But that one is odd, so this is good. Okay? That's all you need to know.